In a remote Chinese weapons testing facility, 1963, a military officer raised an American M14 rifle captured in Vietnam, studying every detail with obsessive intensity. "We will copy this weapon exactly," he declared to assembled engineers. "Within 2 years, Chinese infantry will carry rifles superior to anything the Americans possess." What followed was a decade-long disaster of exploding barrels, jammed mechanisms, and a humiliating admission that Chinese manufacturing couldn't replicate a rifle the Americans had designed in the 1950s. But the story gets worse, much worse. The year was 1962, and China was desperate. The Sino-Soviet split had severed military cooperation with the USSR, leaving China's armed forces equipped with obsolete weapons and cut off from Soviet technical support. The People's Liberation Army infantry carried Type 56 rifles, Chinese copies of the Soviet SKS, adequate weapons, but outclassed by the modern rifles Western nations were fielding. Then came an intelligence windfall. Chinese advisors supporting North Vietnam in the early 1960s acquired several American M14 rifles, some captured from South Vietnamese forces, others from small-scale U.S. advisory units. The rifles were immediately shipped to Beijing, where they landed on the desk of Colonel Zhang Wei, Director of Small Arms Development for the Second Ministry of Machine Building. Zhang examined the M14 with a mixture of admiration and envy. The rifle was everything Chinese weapons were not: sophisticated, powerful, accurate, and representing a leap forward from World War II-era designs. It fired the 7.62 x 51 mm NATO cartridge, held 20 rounds in a detachable box magazine, and was select fire capable of both semi-automatic and fully automatic fire. American soldiers were being equipped with these rifles by the hundreds of thousands. "This is what we need," Zhang told his assembled engineering team during the first examination. "This rifle represents American technical superiority. If we can copy it, we prove that Chinese engineering can match Western capabilities. If we fail," he didn't need to complete the sentence, "failure would confirm that China remained technologically inferior, dependent on copying Soviet designs that were themselves increasingly outdated." But Zhang and his team were walking into a trap they didn't recognize. The M14 itself was a problematic weapon, heavy, expensive to manufacture, and difficult to control in automatic fire. The U.S. military would eventually replace it with the M16 after recognizing these flaws. China was attempting to copy a rifle that even its designers considered flawed, using manufacturing capabilities far inferior to American standards. The impossible specifications. The program was designated Type 63, and from the beginning it was driven more by political imperatives than engineering reality. Chairman Mao Zedong himself had decreed that China must achieve self-sufficiency in weapons manufacturing, reducing dependence on foreign technology. The Type 63 would showcase Chinese capability and prove that revolutionary zeal could overcome technical limitations. Zhang's team began by completely disassembling the M14 rifles. They measured every component, documented every dimension, photographed every detail. They conducted metallurgical analysis to determine steel compositions, examined manufacturing techniques, and created detailed technical drawings of every part. The process took months and revealed the enormous complexity of what they were attempting. The M14 was not a simple weapon. It contained approximately 80 separate parts, many requiring precision machining to tight tolerances. The receiver was forged from high-grade steel, then machined in multiple operations, requiring sophisticated equipment. The barrel was manufactured from specialized ordnance steel, rifled with precision, and required specific heat treatment to achieve proper hardness and flexibility. The gas system that cycled the action demanded precise dimensions and careful assembly. And the fire control mechanism, allowing selection between semi-automatic and automatic fire, was complex and required parts manufactured to exacting specifications. Every component presents challenges, reported senior engineer Lu Ming after initial analysis. The Americans manufacture these parts using equipment and processes we don't possess. The steel alloys are different from what we produce. The tolerances are tighter than our machine tools can consistently maintain. We can create parts that look similar, but whether they'll function reliably is another question. Zhang dismissed these concerns. The Americans are not superhuman, he insisted. Their steel comes from the ground, as does ours. Their machines cut metal, as do ours. If they can build these rifles, so can we. Revolutionary spirit and socialist determination will overcome any technical obstacles. This attitude that political will could substitute for technical capability would doom the project from the start. Zhang wasn't an engineer solving a technical problem, but a political officer enforcing ideological orthodoxy. Engineers who raised concerns were accused of defeatism. Those who pointed out that Chinese manufacturing capabilities couldn't match American standards were subjected to criticism sessions. The environment became one where reporting problems was dangerous, ensuring that problems multiplied unchecked.
The manufacturing disaster. Production of the first Type 63 prototypes began in early 1963 at Steak Factory 56 in Chongqing. The facility had been producing Type 56 rifles, copies of the Soviet SKS, for years, and was considered one of China's premier small arms factories. But producing SKS copies and manufacturing M14 equivalents were vastly different challenges. The problem started immediately with the receiver forgings. The M14 receiver was forged from 8620 alloy steel, a medium carbon steel alloyed with nickel, chromium, and molybdenum. This specific alloy provided excellent strength, toughness, and machinability. Chinese steel mills didn't produce this exact alloy. Factory 56 had to substitute Chinese steel that was chemically similar but not identical. The substitute steel was harder, making it more difficult to machine and more prone to cracking during the forging process. "We're breaking cutting tools constantly," the factory manager reported after the first month of production. "The steel is too hard for our machine tools. We can cut it, but the tools wear out rapidly, and the dimensions drift as the tools wear. We're producing receivers, but many are out of specification." The barrel manufacturing presented even greater challenges. M14 barrels were manufactured from specialized chrome molybdenum steel, button-rifled to create precise spiral grooves, and then chrome-plated on the interior to resist corrosion and extend barrel life. Factory 56 had no chrome plating equipment for rifle barrels. They had to manufacture barrels from unplated Chinese steel, using cut rifling equipment that was less precise than American button rifling machines. The result was barrels that varied significantly in quality. Some were adequate, maintaining reasonable accuracy and showing acceptable wear characteristics. Others had rough bores that affected accuracy and accelerated wear. A few had rifling that was visibly uneven, with grooves of inconsistent depth. Quality control was supposed to reject substandard barrels, but production quotas took priority over quality. Inspectors faced pressure to pass marginal barrels to meet targets. The fire control mechanism, the complex assembly of parts that allowed selection between semi-automatic and automatic fire, proved impossible to manufacture reliably. The mechanism required approximately 20 separate parts, many with complex shapes and tight tolerances. Chinese machine tools couldn't consistently maintain the required precision. Parts that should have been interchangeable weren't. Each rifle required hand-fitting of fire control components, a time-consuming process that defeated the purpose of mass production. "We're building rifles like medieval gunsmiths," one frustrated engineer privately complained. "Every weapon is unique, requiring individual fitting and adjustment. This isn't mass production, it's craftsmanship. And even with all the hand-fitting, reliability is poor." By mid-1963, Factory 56 had produced approximately 30 Type 63 prototypes. They looked externally similar to the M14, the same general configuration, the same length and weight, similar furniture and appearance, but beneath the superficial resemblance, they were deeply flawed weapons that bore little resemblance to the M14's reliability and performance.
The test that revealed everything. The first formal testing of Type 63 prototypes occurred in August 1963 at a military range outside Chongqing. Senior military officials attended, expecting to witness the validation of Chinese technical capabilities. Zhang Wei was confident. His team had worked tirelessly, the rifles looked impressive, and he had carefully selected the best examples from production for the demonstration. The test began promisingly. A soldier loaded a 20-round magazine into the first rifle, chambered a round, and fired single shots at targets 100 meters downrange. The rifle functioned, though observers noted that brass cases were ejecting erratically, sometimes flying forward, sometimes backward. After 10 rounds, the rifle jammed, a failure to extract with the spent case stuck in the chamber. "Minor malfunction," Zhang announced. "Continue testing with another rifle." The second rifle fired approximately 15 rounds before the bolt locked partially open, jammed on a case that had split lengthwise during extraction. The soldier attempted to clear the malfunction but couldn't. The split case was wedged firmly in the chamber, requiring tools to remove. The third rifle made it through a full 20-round magazine, but showed concerning signs. The gas system was venting excessively, suggesting problems with the gas cylinder or piston. The wooden stock had cracked near the receiver during firing, compromising structural integrity. And accuracy was poor. Groups at 100 meters were spreading to nearly a foot, far worse than M14 standards. "Switch to automatic fire," ordered the test commander, wanting to evaluate the rifle's select fire capability. This is when the demonstration turned into catastrophe. The soldier selected automatic fire on the fourth rifle, aimed at a target, and pressed the trigger. The rifle fired 3 rounds in rapid succession, then exploded. The bolt had failed catastrophically, shearing off the locking lugs and flying backward with such force that it shattered the stock and narrowly missed the shooter's face. Fragments of metal peppered the soldier's hands and chest, causing multiple lacerations. He dropped the destroyed rifle and stumbled backward, blood streaming from cuts across his hands. Medical personnel rushed forward while officers stared in shock at the destroyed rifle. The receiver had split longitudinally, the barrel had bulged near the chamber, and the entire fire control mechanism had been blown out of the rifle. The weapon was destroyed beyond any possibility of repair. This is unacceptable," one senior officer stammered. "How did this happen? These rifles were inspected and approved for testing." Zhang had no answers. The catastrophic failure had resulted from a combination of factors: a cartridge that generated excessive chamber pressure due to inconsistent propellant, a bolt manufactured from steel that was too brittle, and a receiver that couldn't contain the forces of firing. Any one of these problems should have been caught during quality control. Together, they had nearly killed a soldier and destroyed any credibility the Type 63 program possessed. The testing was immediately suspended. All prototype rifles were impounded for investigation, and Zhang Wei, who just hours earlier had been confident of demonstrating Chinese technical achievement, now faced the humiliating task of explaining to senior leadership how the program had failed so spectacularly.
The Reckoning. The investigation into the Type 63 failure took months and revealed systematic problems at every level of the program. The steel used in receivers and bolts was inconsistent in quality and often contained impurities that created weak points. The heat treatment processes were inadequately controlled, producing parts with unpredictable properties. The barrels showed significant variations in dimensions and rifling quality. The fire control mechanisms were unreliable, even when they didn't catastrophically fail. And the ammunition, manufactured specifically for the Type 63, showed dangerous variations in chamber pressure from cartridge to cartridge. We attempted to manufacture a sophisticated weapon system using industrial capabilities inadequate for the task, the investigation report concluded. The M14 represents American manufacturing excellence developed over decades. We tried to replicate it in less than 2 years using inferior materials, inadequate equipment, and insufficient expertise. The result was inevitable. We produced weapons that looked like M14 rifles but didn't function reliably and were actually dangerous to the soldiers who would carry them. The political fallout was severe but contained. The program was classified, so public knowledge of the failure was limited. But within military and industrial circles, the Type 63 disaster became a cautionary tale about the dangers of attempting to copy foreign weapons without understanding the underlying technical requirements. Zhang Wei was removed from his position and demoted, though he avoided the harsh punishment that political purges of the era often brought. He had failed, but his failure could be attributed to impossible objectives and inadequate resources, rather than deliberate sabotage. The engineers who had warned about technical problems were quietly vindicated, though most were too wise to openly say, "I told you so," in an environment where being right at the wrong time could be dangerous. The Type 63 project was officially canceled in late 1963, though some development work continued sporadically for several more years before being definitively abandoned. The prototypes that hadn't been destroyed in testing were scrapped, and the technical documentation was filed away in archives, where it gathered dust for decades. The pattern of failure. The Type 63 disaster was not unique, but part of a larger pattern of failed Chinese attempts to copy Western weapons during the 1960s and 1970s. Time and again, Chinese engineers would examine captured or purchased foreign weapons, conclude they could replicate them, and then discover that copying appearance was vastly different from replicating functionality. The fundamental problem was that modern weapons were products of entire industrial ecosystems, not just individual factories. The M14 rifle depended on American steel mills producing consistent alloy compositions, machine tool manufacturers building equipment capable of maintaining tight tolerances, quality control systems ensuring that components met specifications, and accumulated expertise developed over decades of firearms manufacturing. China had none of these advantages. Chinese steel production in the 1960s was quantity-focused, with limited ability to produce specialized alloys consistently. Machine tools were often worn-out equipment inherited from the pre-communist era, or crude copies of Soviet designs. Quality control was weak, with production quotas taking priority over maintaining standards. and the accumulated expertise, the craftsmen, engineers, and technicians who understood not just what to build, but how to build it, was limited. Attempting to bridge this capability gap through reverse engineering alone was doomed to fail. Chinese engineers could measure dimensions and analyze compositions, but they couldn't steal the accumulated knowledge and industrial capacity that made American manufacturing so effective. They were trying to copy the end product of a process without access to the process itself. The political environment made the problem worse. China's totalitarian system punished failure harshly, creating incentives to hide problems rather than solve them. Engineers who reported that objectives were unattainable risked being labeled as counter-revolutionaries or saboteurs. Factory managers faced pressure to meet production targets regardless of quality. And political officers with no technical expertise made critical decisions based on ideology rather than engineering reality. We were set up to fail, one engineer involved in the Type 63 program said decades later, after enough time had passed to speak more freely. We knew from the beginning that we couldn't successfully copy the M14 with our capabilities, but we couldn't say that. We had to proceed as if success was possible, even though we knew it wasn't. And when we failed, we were blamed for not working hard enough or lacking revolutionary spirit, rather than for being given an impossible task.
The long shadow. China continued with struggle with small arms development for decades after the Type 63 failure. The country's standard infantry rifle remained the Type 56, the SKS copy, supplemented eventually by Type 56 assault rifles, which were copies of the Soviet AK-47. Both were adequate weapons, but represented 1940s technology. Not till the 1980s, with the development of the Type 81 rifle, did China field an infantry weapon that incorporated lessons from the Type 63 failure and represented genuine indigenous development rather than copying. The contrast with other nations was stark. The United States, despite the M14's flaws, quickly developed the M16 rifle, which became one of history's most successful military rifles. Japan, South Korea, and Taiwan developed their own infantry rifles using licensed technology and systematic industrial development. Even nations like Israel and Belgium, with limited industrial bases, successfully developed modern rifles by building required capabilities systematically over time. China's approach, attempting to leapfrog developmental stages through copying, consistently produced inferior results at high cost. The resources invested in failed programs like the Type 63 could have been better spent on systematic development of manufacturing capabilities, training programs for engineers and technicians, and incremental improvements to existing designs. The psychological impact within China's defense establishment was significant. The Type 63 failure, combined with similar failures in other weapons programs, reinforced a sense of technological inferiority that persisted for decades. Chinese engineers knew their products were inferior to Western equivalents, but lacked the resources, time, and political support to close the gap. We spent the 1960s and 1970s trying to copy our way to parity with the West. We failed repeatedly because we didn't understand that you can't steal capability. You have to build it. By the 1980s, we finally learned this lesson and began investing in our industrial base, our education system, and systematic development rather than copying. But we lost 2 decades trying to take shortcuts that didn't work.
The lessons that took decades to learn. The Type 63 program failed because Chinese leadership made fundamental misjudgments about the nature of technological development. They believed that revolutionary fervor could substitute for industrial capability, that copying appearance meant replicating functionality, and that political pressure could overcome technical limitations. All of these assumptions were wrong, and the consequences were costly. Modern weapons are systems, not just objects. They depend on materials with specific properties, manufacturing processes capable of maintaining tight tolerances, quality control systems that ensure consistency, and accumulated expertise that allows workers to recognize and solve problems. None of these can be copied by examining finished products. They must be developed through systematic investment in industrial capabilities, education, and accumulated experience. The political environment in authoritarian systems makes successful development harder because honest assessment of capabilities is dangerous. Engineers who report that objectives are unattainable risk punishment, creating incentives to hide problems until they become catastrophic. This dynamic ensures that resources are wasted on impossible projects while achievable improvements are neglected. Finally, the Type 63 story demonstrates the danger of measuring success by superficial metrics. Chinese leadership wanted rifles that looked like M14s, and the program produced weapons that looked similar. But appearance meant nothing when the rifles couldn't function reliably. This focus on appearance over functionality plagued Chinese military development for decades.
The modern context. By the 21st century, China had largely overcome the technical limitations that doomed the Type 63 program. Decades of investment in industrial capabilities, education, and systematic development produced a defense industry capable of manufacturing sophisticated weapons. Modern Chinese infantry rifles like the QBZ-95 and QBZ-191 are competent weapons that, while influenced by foreign designs, represent genuine indigenous development rather than crude copying. But the legacy of failures like the Type 63 persists. China's defense establishment remains haunted by memories of technological inferiority and failed attempts to match Western capabilities through shortcuts. This history drives current efforts to achieve technological superiority through any means necessary, including extensive industrial espionage and intellectual property theft that continues to characterize Chinese approaches to technology acquisition. The Type 63 story also serves as a cautionary tale about the limits of reverse engineering as a development strategy. While examining foreign technology can provide insights and inspiration, successful development requires building indigenous capabilities rather than simply copying foreign weapons. Nations that have successfully developed competitive defense industries, South Korea, Israel, Turkey, and others, have done so through systematic capability building rather than attempts to copy foreign weapons. For historians studying China's military-industrial development, the Type 63 represents a critical moment when Chinese leadership confronted the gap between their aspirations and their capabilities. The program's failure forced a reckoning with reality that eventually led to more sustainable approaches to weapons development. But the lesson took decades to learn, and the cost, measured in wasted resources, lost opportunities, and persistent technological lag, was enormous.
The buried history. Today, the Type 63 program is barely remembered even within China. The failure was never publicly acknowledged, and most documentation remains classified or has been destroyed. A few prototype rifles may exist in military museums or storage facilities, silent testimony to a program that failed comprehensively. Those who worked on the program are mostly gone now, having taken their memories of the failure to their graves. The younger generation of Chinese defense engineers knows about the Type 63, if at all, only as a cautionary footnote in internal histories, a reminder of the dangers of attempting to copy foreign technology without understanding the underlying principles. But the story deserves to be remembered as more than just a failed weapons program. It represents a critical moment in China's technological development, a harsh lesson about the limits of shortcuts and copying, and a demonstration that technological capability cannot be stolen, but must be earned through patient, systematic investment in the foundations that make technological achievement possible. The American M14 rifle that inspired the Type 63, the weapon that Chinese engineers tried desperately to copy, served with U.S. forces for years before being replaced by the M16. It wasn't a perfect weapon, but it was a competent one, the product of a sophisticated industrial system and accumulated expertise. The Chinese attempt to copy it failed, not because Chinese engineers lacked talent, but because they lacked the industrial ecosystem and accumulated knowledge that made the M14 possible. That ecosystem cannot be copied from examining finished products. It must be built through decades of investment in education, research, industrial development, and accumulated experience. China eventually learned this lesson, but the Type 63 program stands as expensive evidence of what happens when political ambition outstrips technical capability, when copying is mistaken for creation, and when the appearance of success is valued more highly than actual functionality. The rifles that nearly killed soldiers during testing became monuments to hubris, reminders that some capabilities cannot be stolen but must be earned through the hard work of genuine development.